We are reacting a weak base with a strong acid. The strong acid is best represented in solution by H3O+. So the relevant reaction is that we have an H3 reacting with H3O+, and our products are going to be the conjugate acid of NH3 and water. So we write our BCA table, before, change, after. We have 4 millimoles of ammonia added to 2 millimoles of hydronium ion, which is our limiting reagent. So all of our limiting reagent has been consumed, and we have consumed 2 out of the 4 millimoles of NH3, but we need to be mindful that we've generated 2 millimoles of our conjugate weak acid. Therefore, in solution, we have some amount of a weak base and its conjugate acid. So we have a weak conjugate acid-base pair in solution. That's a buffer. The relevant equilibrium reaction is that we have ammonia reacting with water in equilibrium with its conjugate acid and hydroxide ion. Henderson-Hasselbalch tells us that pH is equal to pKa plus log base to acid. We have a balanced buffer, meaning we have equal amounts of a weak base and its conjugate acid. We substitute in our values. We see that the second term goes to 0, and therefore our result is that the pH is going to be equal to our pKa.